Share your screen. Okay, so the first thing we're going to do is we're going to go to your copy of your simple machine. Remember what I asked you to do is to go in and on your PowerPoint, you should have your simple machine 1, simple machine 2, simple machine 3, 4, 5, and 6. And the next one is reading the calipers. Is everybody there?
The simple machine PowerPoint 005?
It is one of them, yes.
Lever and.
No, it's not. 007.
This,
Project 1?
Yes.
yeah, that's my simple machine.
Yeah, mine's not that one. Mine's not 007.
It's not, yeah, it's not 007, it's all caps, my simple machines.
It's not there. There is a 007. You just have to click more items. It's gonna be out there.
Yeah.
Once you post it, it's fine.
Yes, I did. And I didn't want to unpost it because some people actually put it on there on that one. And if I had deleted it, it'd get rid of it. Okay, so reading dial calibrator measurements. So here we have on slide 9, we have one. So the very first one, what do you think that number is? 2.5/15, right? Everybody understand? Does everybody agree? All right, so let's look at the next one.
You want to know where the gear notes are from?
I have no idea. So let's look at the next one. This one's a little bit different, but we can still see it. It is 0.9 what? Yeah, looks like it to me, right? So are we feeling pretty good about reading these calipers? Okay, so I wanted to make sure we went to this slide to look at these two because number one, as you scroll up, I'm going to walk around and I want to see your pictures that you have attached. Okay, so if you will scroll up.
Yeah, and I have a question, Ms. Lum.
Yes, sir, you can ask the
The
question.
2 PowerPoints we have seem to be different. They both have the same My Simple Machines thing, but then
Yes,
one is just like, were we supposed to make a copy of this? Because this is just one,
yes,
2, okay, because I was looking at this one, I thought this is where we were supposed to put it.
I understand.
Didn't save, but.
It's fine. So if you have your pictures attached, go ahead and move your pictures into yours.
Wait, so are we-
Okay, you got them, or that's where you put them. Okay, all right. Well, can you do me a favor and put them up there for me too? Just copy that picture and put it up there. Do you have yours done, baby? That's no problem. So what you're gonna do is on yours. This is the copy, but this one doesn't have your name on it. So you'll have to make a copy of this. And then just put your picture here. It's mine. So I came in. All right, so we need to obviously do that this weekend. Right? Yeah.
So. Well,
Yes.
make a copy of this one or use this one? This also has different.
Different.
Calculate. So don't worry about this one.
No, don't worry.
I worked these out. I was going to save. I don't know why.
Should automatically call you? No.
Didn't see it.
Okay. All right, so now everybody understands. Go ahead and close it down, close it out. So I'm not going to check these yet. but make sure that you have included your pictures on this machine section. And at the top, it shouldn't say copy of My Simple Machine. It should have your name. Okay, just making sure. All right, so let's go ahead and get our handout, please, and come sit at our desk. The one on your desk, number 4.
Whiteboards too?
Yes. And you can bring your computer with you today so you can use the calculator. I know, it's awesome. Pick you a desk. What's so great about it is you can leave it at your desk. Your stuff can stay at that desk, so it'll get out of your way. Sit down, Elijah. Come on, everybody. Well, you could have picked a higher one.
Because all of our desks that we set in our other classes, you can't put your knees under them.
Big one. Nobody's had one yet.
I can actually fit my knees under
We have
this.
not even started having these desks started yet. We just went and picked them up yesterday. Okay, so at your desk, you will have your marker, you will have your paddle, you will have your computer, you will have it open to the calculating section, and your handout. And all this beautiful stuff can stay right here. Well, his. I have one that's too short.
God's sake, don't send me.
Well, no, we got nothing.
Yeah, exactly. Well, we're gonna be one desk short, or 2 desks.
We're one desk short today, but he's gonna stay here. So I'm gonna let him stay here, and then you can sit right there. All right, let me record. Oh, it is recording. Okay, so let's look at the very first scenario. Everybody got their paper? We're on 4. Yeah, no, what it is we had handout 1, 2, and 3. This is number 4. All of them are at your desks. We're doing 4 today. 1, 2, and 3 is recorded and it's online for you, baby, so you can see what the answers are and how we work the problems, okay?
Is that this one?
Yes, ma'am, it is that one. Okay, so let's look at the first one. It says the effort needs to push the 75-pound upper ramp. Okay, we had this picture yesterday, didn't we?
It was different measurements.
Yes, ma'am, it was. Thank you. Okay, so it asked us what the effort needed to push a 75-pound weight up a ramp. Well, we don't have any friction, so we're going to go ahead and apply that and say no friction. What formula are we going to use here? Mechanical advantage is what it's asking for. So since it's asking for the mechanical advantage, what we're going to do is we're going to do the distance of the effort over the distance of the force, and then the force, and then the effort and the resistance. Okay, so what numbers are we going to plug in? Plug them on your board, please. Here is your formula. Hope you got your computer back. You go, baby. Log into here for me so I can get your calculator up. Do you have your calculator up there? So you can practice using it? All right, Hope, show me what you got. Okay, please work then. I sure can. I'll put erasers in here. Is that work for you? Got your blue one? We have gold. What are we looking for here? Force, effort, correct. So we know that this one is just going to be the letter, right? What is our force resistance? 75. What is our distance of our effort? 10. And ma'am, distance of our force?
3 feet.
Yep, 3. Remember what we did yesterday? This times this divided by that, please. Put it in your little calculator.
Which ones do you multiply first? The 10 and the FE or the 75 and 3?
I do the 75 and the 3 and then divide by the 10. All right, if you will put your answer on your board and show it to me, please. Okay. Okay. Yep. Uh-huh. And 22.5, and what's my units? Pounds, correct? Because we're talking about weight. So the answer to that question is D. Circle that. Now, if you drew it on your paper, that's fine. Remember, you want to annotate on your paper so that you can have this for a reference when you take your test. And those of you that are done with that, go ahead and look at question number 2, please. So what would be the first thing that we would want to do for this second problem? Draw your gears, right? You're good, Hope. Oh, girl. So A has how many teeth? 10. B has 18 teeth. And C has 16 teeth. Okay? So it says that the middle gear B is turning counterclockwise at a rate if the gear A is moving at 60 RPMs. What formula are we going to use that we used yesterday? We're trying to find the gear ratio.
Output divided by input.
Yep. Gear ratio is the number out over the number in, and WN, which is the width in, and the width out. All right, there's your formula. Let's see if you can find the numbers. What are we looking for here?
How fast B is going.
So the width out. What is our number out? Which would be this one, 18. How about our number in?
10.
That's our A, 10. And what is this one here?
1.0.
RPMs, right. Okay, so Cross multiply and divide, please. Yeah. Please, help yourself. Show me your answer, please. Okay, okay. I'm doing so good. Yep, that's it, Elijah. All right, so the answer to that one is, which is letter D. Perfect. Write you a note. Write whatever you need to write down there to make sense to you. So when you look at this again and study it, you will know how to do a problem if you have one. Gear ratio. And I need to do one. When we get into gears, I'll put that up there. Go ahead and look at the next problem. So it's asking you for the overall gear ratio for A, B, and C gear train. How do you do that? You take the last one and the first one. Okay?
Back to the middle one.
Nope, don't factor the middle one because the middle one's turning based on A and C, right? So our gear out equals number out over number in, which is 16 and 10, which is equal to what? Everybody good? What is our answer?
C.
C, correct, 8 to 5. Take your note. Let's look at our problem number 4. Problem number 4 says, if 15 pounds of torque is applied to a gear, drive gear, and the output at the drive gear is what it's asking for. So what are we looking for? Yep, so that's GR, right? GR equals number out, number in equals total out, total in. So what do we know?
All we have is 15.
Yes, ma'am, but it's referencing the question number 2.
Okay. Wouldn't the drive be A?
So it would be 16 over 10 equals X over 15, or total out over 15.
Yep. Exactly. So what is our answer? 24 feet, 4 pound per foot, which is B. Everybody good so far? Write down you a note if you need it. Number 5 says, what is the weight resistance you can lift using a first-class lever if you apply 24 pounds of effort? The effort arm is 10 feet and the resistance arm is 4 feet. Who thinks they can draw me the lever on the board? Take volunteers first. Wow. Here you go. Thank you, Lex. Thank you. Does it matter if the resistance or the effort's on the left or the right? No. So the first thing that you want to do when you get this problem, you want to draw it out first. Okay? Draw it out on your paper. And then what are we looking for here?
The resistance.
Yep. There is your formula. Plug and chug, please. Is this getting easier?
No.
It will.
Not too shiny like that.
The only thing I ask is you to try your best. And that's all that we can do. And just remember, there's always a video that you can go back and watch. Okay. Let's look at number 6. Wow, we saw this question kind of like yesterday, didn't we, Hope? Okay, Banks, ready? So it says, find the mechanical advantage of a wheel of an axle system if the wheel has a radius of 1.5 feet and the axle has a radius of 6 inches, is force is put on the axle. So what I'm going to do is I'm going to draw my circle, right, sir? And then I'm going to have this. Remember this picture yesterday? Okay. What is the thing we need to remember about our calculator this time?
It has to be in
Degree.
Has to be in degrees. All right, so we're looking for MA again. That is diameter of the effort over the diameter of the resistance. So, sir, can you tell me what the diameter of the effort over the diameter of the resistance is? Which one do you think is the effort?
Effort will be 6 inches, right?
Yep. So it would be 6 inches over 18, right?
That's radius though, not
Where'd you
diameter.
get 18 from?
Yes.
Yeah. Where'd you-
18 would be 1.5 feet,
Oh,
but yeah, you have to double that.
Okay. Sorry, it was my misspoken word. So the answer to that, this is a fraction, but what can we reduce it to?
1/3.
1/3. Apologize. Everybody good? Let's turn to the back page, number 7.
So, Ms. Long,
Yes, sir.
in a wheel and axle, when would you use the circumference? What calculation is that using?
Efficiency. If you're buying a tire and you want to know about efficiency and how long it's you'll be able to ride on it and things like that, that's when you would use that. Because the
And is it-
efficiency depends
Is it also
on,
used for like figuring out, like if the problem says how far does the wheel go or something?
Yes.
Okay, that makes sense.
Yeah. Yeah, the mileage,
Rotation
and
of
that goes with the
circumference
efficiency.
in a linear direction.
Perfect. Thank you, Sam. Alrighty, let's go. Let's see what we got. All right, it says, vehicles have an engine that uses a small axle effort to turn a much larger wheel against the ground load. In this scenario, which of the following best describes the mechanical advantage? So write your letter on your board, please. Look at all the scenarios. Okay. I thought. Okay. Yep. Same thing you did? Hmm, so she?
What do you put?
Yes, the answer is C. Okay?
I'm not saying you're bringing cars that, yeah,
Yeah,
plus you just don't need.
that's the value.
Can you explain it?
So if one is a small axle and the other one's a larger one, that's where you get your 0 and a 1. And we're talking about, you remember how we did the efficiency, mechanical advantage greater than 1 or less than 1? At the very beginning? Okay, it's, okay. But that's where we get that at. But it was a very good guess for everybody. Is that how y'all guessed it, or y'all just said, hey, I'm gonna choose the one with the longest words?
Well, because I know that
No.
if it's a smaller axle turning a larger,
That's what I was.
I am being
heavier
serious.
thing, it's gonna be, it can't be 0 or anything, because then it
There is
wouldn't
no
work.
mechanical
And
advantage.
it can't be more effective at turning it, because that's just not how the wheel and axle thing
And if
works.
it was a 1, they would have been the same.
Yeah,
Yeah.
Yes,
it
one
would
and
have to
one.
be the same size.
And then
for
if
to
it
be
was
one.
a greater than 1, it would be bigger and then smaller, rather than smaller and bigger. That's how I guess.
Wow,
It was a guess.
those were very scientific too, by the
I
way.
guess it wasn't a guess.
No, it wasn't. Yeah, we're using your mind. You're just great. Wow. Okay, let's look at the next one. Determine the mechanical advantage of the pulley system shown in the diagram on the right.
I'm trying to figure out if it's the first class ever.
Yep. Let's see what y'all got with your letters. Uh-huh. Uh-huh. We're doing fantastic.
I don't know what it is.
Oh, yes, sir. It is C. Why is it C?
These are 7 strands.
Yeah, you gotta count them, but they're kind of hard to.
Really, you got 8, but you have to.
Yeah, but you're not
That
counting,
one
you're
doesn't
not counting the
because it's
other one.
not going back through, it's like separate.
It's an
'Cause
effort,
technically in most things, it could also be on top or whatever. before, so.
but it has to be around
You
enough.
always minus 1. If you count all of them.
That's, and you know what? Elijah has a very good thing. Count them all and subtract 1, because you always have the effort one that you're trying to pull down.
The
We're
strands.
counting the strands.
Just the lines, basically.
Yeah, you know the rope that goes around the pulleys? Okay, let's look at number 9. A pulley with support stand would require 30 pounds to lift. How much weight in pounds? Okay, so, how can we figure out which one are the supporting strands?
So,
How can we decide that there's 3 supporting strands in here? 1, 2, 3.
Wait, I don't think this is about the picture.
It's not about the picture?
It's separate, because it says
It's a
A
different
pulley.
Dang, I need it by the picture. Well, maybe mine's wrong then.
Because I think 7 supporting strands is how that works. And then in the next one, since it has 3 strands, that would be the mechanical advantage of 3, so you just multiply 30 by 3, the effort force by the.
Oh, oh my
So
gosh.
it's C, right, Liz?
So I overthought it then. Dang it. Because this,
Yes,
you
it
told me
does
the
look down,
number,
like, it seems like
and I'm like, I used that.
wait, so what is it?
It reading the problem, Elijah, I'll talk to you for a second because I just understood. Reading the problem, it tells you have 3. Okay? It has nothing to do with the first one. And it's telling you that that is 30 pounds of weight that you're lifting. You're looking for FR. So you take your 3 FR over 30, multiply those together to get your FR. That's all you had to do. Yes, it's simpler than what I thought. Okay, the fixed point of the rotation of the lever is at its where? Everybody should know this answer. Courtroom, A. Okay, go back to your table, take a picture.
It's just so much hard.